Imagine you are embarking on the longest road trip of your life, but for the first time in a decade, that cold shiver of battery dread is completely gone. No more frantic searching for a charging station in the middle of nowhere. No more sitting in a depressing parking lot for 2 hours staring at a slow-loading percentage bar. The story of the electric vehicle is about to undergo a violent and total transformation. CATL, the undisputed king of battery manufacturing, and Toyota, the legendary titan of the automotive world, are finishing a weapon that will redefine human mobility forever: the solid-state battery. It sounds like a dry technical term, but the reality is a monster that doubles your range, charges in the time it takes to buy a soda, and, most importantly, literally cannot catch fire. Is this the final nail in the coffin for charging anxiety? Or is it another billion-dollar broken promise? And if this succeeds, what happens to the empire Elon Musk built? Stay tuned until the very end, because we are revealing one secret reason why this technology will not just change the industry, but potentially bankrupt every company that isn't ready for it. Before we dive into this mechanical apocalypse, hit that subscribe button to be the first to witness the death of the old EV world. The global landscape of transportation is currently trapped in a state of suspended animation where the initial euphoria of the electric vehicle revolution is beginning to collide with the harsh and unforgiving walls of physical reality and consumer psychology, because while the media and the politicians have spent years painting a picture of a seamless transition to a green future, the actual experience of the average driver on the road remains plagued by a series of fundamental compromises that prevent the electric car from becoming a universal replacement for the internal combustion engine. When we look beneath the polished marketing campaigns of the world's leading EV manufacturers, we find a truth that the industry is desperate to hide, which is that the lithium-ion battery technology we rely on today has essentially reached its absolute ceiling of performance and safety, leaving us in a technological stalemate. This is exactly where the strategic alliance between the Chinese battery sovereign CATL and the Japanese engineering fortress Toyota becomes the most important story in the history of modern industrial development, because they are not just trying to build a better battery but are instead attempting to perform a total heart transplant on the entire concept of the automobile. To understand why this shift is so critical, we must first examine the deep-seated invisible wall of consumer distrust, which is rooted in three primary failures of the current generation of vehicles: the agonizing charging times, the rapid degradation of energy capacity, and the terrifying specter of battery fires that are impossible for standard emergency services to extinguish. Even today, in our hyper-advanced digital age, filling a tank with petrol or diesel remains a simple 5-minute task that allows a driver to continue their journey with absolute confidence, while charging even the most expensive luxury EV can still take anywhere from 40 minutes at a high-speed station to 12 hours on a home setup, creating a waiting culture that is fundamentally incompatible with the fast-paced demands of modern life. This creates what psychologists call charging anxiety, a persistent background stress that ruins the experience of long-distance travel and forces drivers to plan their entire lives around the availability and reliability of a charging grid that is often broken or congested. Furthermore, the issue of battery degradation means that an electric car is essentially a depreciating chemical asset that loses its vitality and driving range every single year, leading to a collapse in resale value that makes the middle class hesitant to trade in their reliable gasoline vehicles for a machine that might have 30% less utility after only 4 years of use. This is compounded by the rare but spectacular news of thermal runaway, events where the liquid electrolyte inside current batteries becomes a volatile fuel for a self-oxidizing fire that turns a minor accident into a catastrophic inferno. This brings us to the technical revelation of the solid-state battery, which is designed to surgically remove the liquid heart of the battery and replace it with a solid-state electrolyte made of ceramic glass or advanced sulfide compounds, which serves as a stable and non-flammable bridge for ion transfer between the anode and the cathode. In the traditional lithium-ion systems used by Tesla and other major brands, the liquid electrolyte is the primary source of instability and danger because it is prone to leaking. It is highly sensitive to extreme temperatures, and it facilitates the growth of dendrites, which are microscopic metallic spikes that eventually puncture the internal separators and cause internal short circuits. By shifting to a solid medium, Toyota and CATL are effectively creating a fortress of energy storage where the risk of fire is reduced to almost zero because the solid electrolyte is inherently thermally stable and physically robust enough to prevent dendrite penetration even under high-stress conditions. But the true game-changer of this structural redesign is the massive leap in energy density because a solid electrolyte allows for the use of a lithium metal anode instead of the traditional graphite anode, which effectively triples the amount of energy that can be stored in the same physical volume and weight. Imagine a battery pack that is 40% lighter than a standard Tesla battery, but provides over 1,000 kilometers of range on a single charge, while also being capable of absorbing a full recharge in under 10 minutes without overheating or damaging the internal chemistry. This is the missing puzzle piece of the electric revolution because it removes every logical argument for keeping a gasoline engine, and it transforms the EV from a city-bound commuter toy into a transcontinental beast that can handle the toughest climates and the longest highways on the planet. The engineering teams at Toyota have spent over a decade accumulating a massive fortress of over 1,600 patents in the solid-state field alone because they realized very early on that the company that controls the solid electrolyte will control the global economy for the next 50 years. While the world was mocking Toyota for being slow to enter the all-electric market, the engineers in Japan were actually playing a long-range game of industrial chess, waiting for the right moment to bypass the current era of compromises and leapfrog straight into the final form of transportation. This strategy is not just about a better battery, but about a total reinvention of the manufacturing process where solid electrolytes must be produced in ultra-dry, clean rooms with a level of precision that makes traditional car assembly look like blacksmithing by comparison. CATL, for its part, is using its massive manufacturing scale and its dominance of the raw material supply chain to ensure that when this technology is ready for the mass market, it can be produced in the millions to drive the cost down to a level that the average consumer can actually afford. We are witnessing the birth of a new era where the battery prison is being broken and the era of the liquid electrolyte is coming to a violent end. The impact on the global energy market will be absolute because a solid-state world means that oil demand will finally face its true existential threat not from government mandates but from a superior product that simply performs better than anything we have ever seen. As we dive into the next section, we will look at how CATL is specifically positioning its half-solid intermediate technology to gain a foothold in the market, while Toyota prepares the ultimate fully solid blow that could reset the automotive hierarchy forever. As the global energy war transitions from a theoretical debate into a brutal industrial reality, we are witnessing a high-stakes game of geopolitical and technical chess that pits the world's most innovative battery sovereign, CATL, against the legendary engineering pride of Japan, the Toyota Motor Corporation. To understand the sheer magnitude of this conflict, one must look past the flashy car reveals and dive deep into the microscopic world of ions and electrolytes where the very soul of the future is being forged, because while the Western world was distracted by the charismatic marketing of Silicon Valley, the Eastern giants were quietly building a technological Maginot Line that is now ready to collapse the current electric vehicle hierarchy. At the heart of this confrontation is a fundamental disagreement about how to bridge the gap between today's flawed liquid batteries and the holy grail of solid-state perfection. And the strategies chosen by these two titans couldn't be more different. CATL, under the visionary leadership of Robin Zhang, has adopted a philosophy of evolutionary dominance, realizing that the jump to a fully solid-state battery is a mountain too high to climb in a single leap, which is why they have unleashed their condensed battery and semi-solid prototypes upon the world. These condensed matter batteries are a masterstroke of chemical engineering, boasting an incredible energy density of 500 watt-hours per kilogram, which is nearly double the density of the most advanced cells found in a high-end Tesla Model S today. CATL's strategy is brilliant because they have created a bridge technology that uses a semi-solid, gel-like electrolyte that provides many of the safety and density benefits of a solid-state system while remaining compatible with existing mass-production gigafactories. This allows CATL to maintain its overwhelming 39% global market share while simultaneously preparing the world for a future where range anxiety is a ghost of the past. In 2025 and 2026, CATL began demonstrating that their condensed batteries aren't just for cars. They are powerful enough to electrify civil aviation, a feat previously thought impossible due to the weight-to-power ratio of traditional lithium-ion packs. While CATL builds the infrastructure of the present, Toyota is fortifying the fortress of the future, having accumulated a staggering portfolio of over 1,300 patents related to all solid-state batteries, a collection that dwarfs the combined intellectual property of almost every other automaker on the planet. Toyota's approach is a revolutionary strike, characterized by a decade of silent, obsessive research into sulfide-based solid electrolytes. Unlike the oxide-based electrolytes favored by some startups, which are stable but brittle and difficult to manufacture at scale, Toyota's sulfide route offers superior ionic conductivity that actually rivals the flow of liquid electrolytes, allowing for the lightning-fast 10-minute charging speeds that have become the centerpiece of their 2027 to 2028 roadmap. But to achieve this, Toyota had to solve the dendrite nightmare, the tendency of lithium ions to form microscopic, needle-like spikes that pierce the battery's internal structure and cause catastrophic failure. Through a proprietary combination of stack pressure and self-healing materials, Toyota claims to have finally tamed the lithium metal anode, allowing them to promise a range of 1,200 kilometers, enough to drive from London to Rome on a single charge. Now we must address the elephant in the room: Tesla and their much-hyped 4,680 cylindrical cells. For years, Elon Musk has touted the 4,680 as a revolutionary leap forward, focusing on the tabless design and the dry electrode manufacturing process to reduce costs and increase structural strength. However, when you strip away the hype and perform a clinical teardown of the 4680 cell, a sobering truth emerges. It is still, at its core, a liquid-based lithium-ion battery. While Tesla has succeeded in making the battery part of the car's structural frame and reducing internal resistance, the energy density of the 4,680 currently hovers around 240 to 290 watt-hours per kilogram. A respectable figure, but one that looks increasingly primitive compared to the 500 watt-hours per kilogram being teased by CATL or the theoretical limits of Toyota's solid-state prototypes. Tesla is optimizing the past, while Toyota and CATL are inventing the future. Tesla's reliance on liquid electrolytes means they still have to deal with the inherent risks of fire and the logistical weight of massive cooling systems, whereas Toyota's high-performance solid-state roadmap targets a battery height of just 100 millimeters. So thin it allows for radical new aerodynamic car shapes that further extend range. The rivalry between these giants is also a battle for raw material sovereignty because the world's supply of lithium, cobalt, and nickel is finite and geographically concentrated, leading to a lithium cartel that threatens to keep EV prices high forever. This is why CATL's secondary move into sodium-ion batteries is so critical. By using common salt instead of rare lithium, they are creating a Plan B for the global economy that ensures even the most budget-friendly vehicles can participate in the electric shift. Meanwhile, Toyota is collaborating with Japanese chemical giants like Idemitsu Kozen to build a massive supply chain for lithium sulfide, ensuring that they control the fuel of the future from the mine to the motor. This is not just a competition between car companies. It is a battle between the cylindrical empire of Tesla and the solid-state shogunate of Japan and China. As we look toward the 2027 milestone, the stakes couldn't be higher because if Toyota's 1,200 kilometers solid-state Lexus flagship hits the road as promised, it will render every current long-range EV obsolete overnight. The resale value of liquid battery cars could collapse, and the global charging grid would need to be entirely reimagined to handle the massive 800-volt bursts required for 10-minute charging. The question is no longer about if the solid-state revolution will happen, but who will be the first to move it from the laboratory to the driveway. Will CATL's pragmatic, semi-solid approach win the mass market, or will Toyota's total solid victory rewrite the laws of physics? This industrial war is being fought in the dark clean rooms of Aichi and Ningda, far from the cameras, but the shockwaves will soon be felt on every highway on Earth. Despite the glittering promises of a 1,000-kilometer range and lightning-fast charging speeds, the road to a solid-state future is currently blocked by a formidable valley of death that separates a perfect laboratory prototype from a profitable mass-produced vehicle, because in the world of high-stakes chemical engineering, what works flawlessly in a sterile vacuum-sealed clean room often fails catastrophically when subjected to the brutal vibrations and temperature swings of real world. Driving the primary scientific demon that Toyota and CATL are currently wrestling with is the phenomenon of volumetric expansion, and the resulting microscopic cracks that form within the solid electrolyte during every single charge and discharge cycle. Unlike a liquid electrolyte that can flow and adapt to the changing shape of the lithium ions as they move back and forth, a solid ceramic or sulfide layer is rigid and brittle, meaning that as the lithium metal anode expands, it puts immense physical pressure on the electrolyte, causing tiny fractures that eventually grow into massive structural failures. These microcracks act like canyons for lithium dendrites, to grow through, which ultimately leads to a short circuit and the sudden death of the battery pack. Toyota's secret weapon to combat this brittleness is a proprietary stack pressure system that keeps the entire battery under constant high-intensity compression to literally squeeze the cracks shut as they form, but the engineering required to maintain this pressure over 10 years of a car's life adds a layer of complexity and weight that the industry is still struggling to optimize for the average consumer. Furthermore, the issue of scale and cost remains the ultimate gatekeeper of the solid-state revolution, because while today's lithium-ion batteries have seen their prices drop by 90% over the last decade, due to massive gigafactories, the materials required for solid electrolytes, especially the high-purity sulfides and specialized ceramics, are currently 10 to 20 times more expensive than their liquid counterparts. If a solid-state battery adds $20,000 to the price of a mid-sized sedan, it will remain a luxury toy for the elite rather than a tool for global decarbonization, which is why CATL is focusing so heavily on their dry electrode manufacturing process to strip away the costly and energy-intensive drying ovens that define today's battery plants. This is an industrial war of attrition where the winner will not be the company with the best chemistry, but the company that can manufacture 1 million units with zero defects, because even a single microscopic dust particle in a solid-state assembly line can cause a total failure of the cell. This is where Toyota's decades of experience in lean manufacturing and Kaizen will be put to the ultimate test, as they attempt to move from producing hundreds of prototypes to hundreds of thousands of Lexus and Toyota flagships by the end of this decade. The geopolitical and environmental impact of this success would be absolute, as it would potentially signal the end of the lithium wars and the beginning of a truly decentralized energy era, because once the range barrier is broken, the need for a massive charging station on every corner begins to diminish. A car that only needs to be charged once every 2 weeks for 20 minutes changes the very nature of our power grid, reducing the peak load stress that currently keeps utility companies awake at night. This transformation would also deal a final blow to the internal combustion engine's last remaining advantage, which is the energy density of liquid fuel, effectively making the petrol station a relic of a primitive industrial past. For developing nations that lack a robust electrical grid, the solid-state battery is the leapfrog technology that allows them to adopt clean transport without needing a charging station every 10 miles. We are witnessing the final minutes of the old automotive clock, and as the hand moves toward 2030, the question is no longer whether Tesla can maintain its lead, but whether anyone can survive the shockwave of a solid-state victory. This brings us to the ultimate secret of the solid-state revolution, which is its secondary life potential, because these batteries are so stable and so durable that once they finish their 15-year life inside a car, they can be removed and used as stationary energy storage for homes and hospitals for another 30 years without losing significant capacity. This creates a circular economy where energy is never wasted and the carbon footprint of manufacturing a battery is spread over half a century of use, making it the most sustainable invention in human history. As we close this glimpse into the future, it is clear that the map of the world is being redrawn in the laboratories of Japan and China, and the names we trust today might be the footnotes of tomorrow. If you want to stay ahead of this mechanical apocalypse and understand the deep tech that is about to bankrupt the giants of the past, then you must subscribe to this channel and turn on all notifications, because we are tracking every breakthrough, every patent, and every industrial move in this race to the finish line. The future isn't just electric, it is solid, and we are just getting started.